equation, or this lesson is on 2.5, which is fractional, or also known as proportional equations. So I'm going to show you going back to what you guys did probably even in 6th grade and then again in 7th grade. And now we're going to apply some of those same concepts to what we do in solving proportional or fractional equations. You'll do more of this again in 9th grade as well. So first thing, if you remember when you were solving equations, when you were solving proportions, you would cross multiply. So we'd do 9 times x, and then you'd set it equal to the other cross product. So 8 times 72. So then you'd have 9x on this side, and it would equal 576 on this side. And then from there, you would solve your equation, and you do divide by 9, so x would equal 64. A lot of your teachers probably taught you cross multiply where you can, so you'd cross multiply 8 times 72, and then they'd say divide by the leftover. I've heard it like fishy method or something like that. Same idea. So on this one, we set each cross product equal to each other. So we'd cross multiply here, so 6 times 2. 6 times 2x, and then this way we set it equal to 4 times 3, which means we'd have 12x is equal to 12. Our last step is to get x alone, so you divide by 12, leaving you with x equals 1. So those were the ones that you've done before. So we're going to use that same concept and apply it to more equations that are set in proportions, or we'll make them so that we can use that concept. So step number 1 is you're going to cross multiply both directions. So this way and this way. And you are going to have to distribute on some of them. So if there are 2 things over there, you're going to have to distribute. Then we're going to set the answers equal to each other. And then we go back to just solving for that variable. So the reason I waited to post this one is because you are going to have variables on both sides. You had to know how to solve for variables on both sides before you could do this. So our first one, as you can see, we're going to multiply that together, and we're going to multiply this together. So that means that I'm going to have 10 times x plus 5 equals 7 times 5, or 5 times 7. So then I'm going to distribute, because there's parentheses, which means I'm multiplying. So I'd have 10x plus 50 equals 35. And then we just solve like normal. Our goal is to get x alone, so this is stuck. We're going to subtract 50 from both sides, leaving me with 10x. This will 0, and this will give me negative 15. Some of you worried because you're going to get a fraction or a decimal on this depending on how you leave it. Our last step is to divide by 10, leaving me with x equals, I personally would leave it as a fraction. Most of you will change it to negative 1.5. So that will work. Or if you wanted to just simplify that, you'd get negative 3 halves. Either answer is acceptable, and both will be marked correct. So our next one, you'll notice this one is in a fraction. This one doesn't have fraction. So first thing we're going to do is we're going to turn it into a fraction. All we do is put that one on the bottom. So we're going to cross multiply here, and set them equal to each other. So we're going to have 1 times 3 plus 3x is equal to 3 times 4. So distributing, I'd be left with 3 plus 3x equals, and then 12 on this side. I need to get this alone, so I'm going to subtract 3 from both sides. 3 positive, 3 negative, 0 out, leaving me with 3x equals 9. Last step would be, right now I'm timesing, so the opposite is to divide, leaving me with x equals 3. Here's a perfect example of one where it's both are fractions already, and there's going to have to be, again, some distributing. So we're going to multiply here. So we're going to have 20 times x plus 6, and we're going to set that equal to our cross product of 9 times 6, or 6 times 9. It would be the same thing. So we'd end up with 20x plus 120 equals 54. Our goal, again, to get x alone. So this is stuck. I'm going to subtract 120 from both sides. This will leave me a 0 here, and 20 times x on this side, equaling negative 66. Again, you're going to get a decimal or a fraction here. It's fine. You have those in life. So you could simplify that and get 33 over 10, or most of you, a negative 33 over 10, most of you will just change it to negative 3.3. Either one's fine. If it comes out as a big, long, huge decimal, leave it as a fraction. Convert it back to a fraction. The higher up in math you go, the more likely you'll be to leave it as a fraction. All right, I'm going to go over H with you, and then I want you to pause and try I and J on your own, and then come back and check to see how you did. So again, I'm going to cross product here. So I have 6 and then m minus 2 on this side. So 6 times m minus 2, the quantity of m minus 2. And then on this side I have 3m, or m times 3, but you're going to see it written that way. So we have 6m minus 12 is equal to 3m. Here's a perfect example of why you needed to understand variables on both sides. Currently, I only have variables on the right-hand side. So I'm going to move these variables to this side so that I have variables on one side, numbers on the other. So to move 6 positive m's, I need to subtract them. So that zeroes them out on this side, leaving me with negative 12. And 3 minus 6 is negative 3, so it's 3 negative m's. Then my last step now, I have numbers on one side, variables on the other. I'm going to divide, leaving me with m equals 4. All right, I want you to try these ones on your own, and then come back and check to see how you did. So pause right now, pause, and then come back and check. And there are your answers. Hopefully you paused and tried them on your own so you know how to do them when you get to your assignment.